Number 4 says, know the 3 laws from this chapter. The law of conservation of mass, the law of definite proportions, and the law of multiple proportions. So we'll get some examples for you on this one. So conservation of mass says what? Yeah, mass of reactants must equal the mass of products. How come? Because atoms can't be created or destroyed. So whatever atoms you start with, you end with. Some of them might recombine, some of them might not recombine, but regardless of whether they recombine or not, what you start with, you end with. So the mass before and the mass after have to be the same. Now, if you think about a campfire, like, really, how's that possible? I got that big pile of wood, and when I get done, there's nothing there. Well, that's because you let all the gas and stuff escape. So this is assuming you keep everything in a container, what we call a closed system. So as long as nothing can get in or out of the container, the mass before and the mass after have to be the same. So here's an example. This is like number 1 on the jump start today. If 6 grams of hydrogen is combined with oxygen and 54 grams of water forms, how much oxygen was used or reacted? So I'm taking hydrogen plus oxygen, and I'm making water, and I said 6 grams of hydrogen. I don't know how much oxygen, but I know I got 54 grams of water. Well, if I look at that, how much oxygen had to be in there? Yeah, if I take the 54 minus 6, another 48 grams showed up in the water. That has to be the oxygen because there was nothing else there. If there's only 6 grams of hydrogen, the only other thing there is oxygen, and I mysteriously get 54 grams of product, then it's 48 grams of oxygen. So what's the law of definite proportions say? What's definite mean? Something's definitely going to happen. Yeah, like for sure. Okay, it's set. So defined means something is a known amount. So if you have, just like it says up there, if 2 substances have the same elements in the same proportion, then they have to be the same compound. And then the reverse is true. They can only be the same substance or the same compound if they contain the same stuff in the same proportion. So it goes both ways. So what's a proportion? The proportion can either be, you can look at the mass ratio, or you can look at the mass percent. So my example says carbon dioxide has the formula CO2. So what does the mass ratio of oxygen to carbon have to be if it's formula CO2? Well, here's another example where I didn't give you any numbers. So where do I expect you to get the numbers from for this? The periodic table. So CO2 tells you have how many carbon? CO2 means how many carbon? 1, because there's no number after it. Chemists are lazy. We're not going to put all those 1s in. So there's 1 carbon. If you look on your table, you should see it weighs 12.01. And then oxygen, the O2 means there's 2 oxygen, and they weigh 16. So this is actually 32. So the mass ratio, you're being asked from oxygen to carbon. So you should take 32 divided by 12.01. And what is this, like 17.175? It's got to be more than that. Actually, it's got to be like 2 something. 2.66, 2.64. So really, when I look at this, I write it as 2.64 to 1 or more often. You might have seen Ms. Felice do this as well, 2.64 to 1 like this. Why do we write it like that? Because it's telling us there's 2.64 grams of oxygen for every 1 gram of carbon. That's why we include the 1, so you don't forget you're comparing it to carbon. 2.64, 2.66, I don't know, I don't have a calculator. You're getting 2.66 when you do it? That's fine. That's in any CO2 molecule. Because if there's not 2.66 grams of oxygen for the 1 gram of carbon, then it's not CO2, it's something else.